See guys, in this lecture I am going to give you a brief introduction to a very important data structure which is called linked list. Basically, a linked list, first let me tell you, a linked list has three types. It's a linear linked list, then circular linked list, and then doubly linked list. Okay, so there are three types of linked lists. This is a linear linked list. In this linear linked list, you can see that I have some structures like these are called nodes. This is the first node, this is the second node, NODE node. This is the third node and fourth and fifth one. There can be umpteen nodes. There is no restriction on the number of nodes for a linear linked list or any kind of linked list. Okay. So you can clearly see in each node there are essentially two elements. The first element is data, another is link. This is just a name which could be anything. Data means whatever data you are storing in the node. So data could be roll number of a student, registration number of a student, employee code of an employee, or it can be flight number, train number, anything. So this is the data and this is the link. Now let me tell you that data part of the node would contain the data and link part would contain address of the next node, right? So essentially the link part, the link element is nothing else but this is a pointer variable. So like in this case, in the case of first node, this link contains address of the second node with the value 200 or it could be any value. And in the second node, we people have got a value of 200, which is data. And in the link part, we are containing the address of the next node, that is the third node. Then in the third node, where the data value is 300, we have got another, the link part, which is containing address of the fourth node. Then fourth node, link of the fourth node is containing address of the last node. So this is how the linked list is formed. You can see each node consists of two parts. One is data, another is link. Data would be containing the simple data, whatever is to be stored in the node, and link part would be containing the address of the very next node. So again, let me repeat it, that link is nothing else but it is a pointer variable. And as you can see, there is a special pointer variable which is called start, or it could be named anything, that would contain address of the very first node. So whenever I want to traverse, that means I want to access all the nodes of a linked list, I would first pick up the address of the very first node from the pointer variable start, and then I will move to the first node by taking the address of the first node from the start. And from the first node, I would get hold of the address of the second node. Then from second link of the second node, I would get hold of the address of the third node, and so on. So it is a linear linked list. And another thing, you can see the link of the last node contains null. As you know, null is basically used in case of pointer variables. Null means this pointer variable contains no address. Why link of the last node is containing null? Because it is depicting that there is no further node. This happens to be the last node. That is why its link is containing null. So far so good. Now let me tell you about circular linked list. As you can see from the heading, I am going to tell you the circular linked list. Circular linked list is almost in the same way as the linear linked list, but with one difference, and that difference is the link of the last node does not contain null, but rather it contains address of the very first node. As you can see, this is the last link of the last node. Now its pointer variable link contains address of the first node, right? So you can easily gauge that whatever is contained in start, the same is contained in the link of the last node, right? Because both are containing address of the first node. Now let me tell you about doubly linked list. Doubly linked list is a linked list where each node contains two pointer variables. The first pointer variable can be called prev, or it could be called anything. It would contain address of the previous node, and link, as we have seen in the previous examples also, link is going to contain address of the next node. So let me tell you that in this case there is not only start, but there is also another variable, pointer variable end. start, as you already know, would contain address of the very first node, and here in case of doubly linked list there is another AND called AND that would contain, this pointer variable would contain address of the last node. For simplicity, I have shown you only 3 nodes. There can be any number of nodes. As you can see, in the case of prev would contain address of the previous node, link would contain address of the next node. So in the case of first node, the prev pointer variable is containing null. Why? Because there is no previous node, because this happens to be the very first node. Hence its prev would contain null because there is no previous node. Now, so link contains address of next node with the value 100, or it could be anything. By chance I have taken the values of all these nodes as 100. They can be different values, nothing like it's not something important. So like in the case of second node, as you can see, the prev pointer variable of the second node contains address of its previous node. Because it is a second node, its previous node happens to be the first node. Hence this prev is containing address of the first node. And in case of link, it is containing address of the very next node, which is the third node. And see carefully, the prev of the third node is containing address of the second node, because second node is the previous node of the third node, as you can see. And naturally, the link of the last node would contain null because there is no next node in this case, and is containing address of the last node. So I have just given you a brief description of 3 types of linked list. We will be learning a lot about linked list in our subsequent lectures.